All right, so what we're going to do is we're beating EMF stuff and equipment into everybody's head, so that everybody here is generally familiar with it, but in order to really make you a good investigator, we're going to sort of continually be making sure that you really understand what you're looking at, the equipment that you're using, and obviously the functional parameters of that equipment. So the basically three devices, the standard devices, this particular EMF reader, the K2, which we've seen, this is the tri-field natural. There's also a tri-field that looks exactly like it, except the faceplate is tan instead of blue. And essentially, and as far as EMF, which stands for electromagnetic field, those are the three instruments that we're using. There's some other more sort of exotic stuff that we use, but it's not stuff that investigators generally are going to be using. And of course, and then this thing which you guys have seen, and I always reiterate, you'll see this when you see this out. If it's on the floor or on the table or anything, don't touch. Okay, you touch, it's gonna hurt. So this is just a little ion cannon, but the voltage at this little point in here is 7,500 volts. Okay, so that can burn the crap out of it. So you see this, and
how many amps?
3.5 milliamps.
Can you maybe paint it red or something?
Well, no, it's got a little red light on it.
Can it glow in the dark or something?
Yeah, well, no, it does actually. You'll see, or if you've seen on investigations, if you're in a dark room, you will see little purple glowing points in every one of these.
And a little bit.
That way you don't actually back up to something.
You're like, well, what's that?
You see it in the dark.
Okay.
Right, so that's just a word on this, and we'll always remind you this. Nobody's been bitten yet, but certainly there have been cases, TAPS runs open ion cannons, and, it's the same thing. And we're also looking at running some much larger ones.
And that's an ion?
Well, so we'll go off a side thing on this right now. So basically what we're talking about in relation to ions in as far as this discussion, so what you have in a normal atmosphere that has like a general, we're not too humid, we're not too dry, so you have nitrogen, oxygen, water molecules in the air. Okay, so these molecules are going to share an extra electron. So they're going to be, there's going to be X number of extra electrons in the air. And the anecdotal information is that helps whatever type of event that may happen. In other words, you're sort of supplying a power supply for an event that might happen.
And what is it called?
Well, it's called an ion.
No, the machine?
That's an ion cannon.
An ion cannon.
Right, or an ion generator. This one's, so, in the general industry, like this function can be used to clean the air, because you'll have negative ions attached to dust particles, which will then become very heavy and drop to the floor, and therefore clean air. But that happens inside of a grid. This case, this is designed to just blow ions out and not really, do the dust thing. So that's the ion generator. So let's get back to, we'll start with our K2. So electromagnetic fields. The relationship between electricity and magnetism is very simple. If you take a magnet, and a magnet we all know has poles, north and south, right? But if you take a magnet and you cut that magnet field with a free electron substance, say like copper, okay, if you cut that field at 90 degrees, you induce a current. So that is the relationship of magnets and electricity. And it works the other way as well. If you have electricity flowing, you will induce a magnetic field, right? So it's a two-way street. It's like if you take a bunch of magnets and you swing it around, right, and you crank it around, coils of copper wire, like so the magnets pass, you will produce electricity, just like the way, you know, water flows through a dam, spins the thing, electricity.
Okay. Shaker lights.
Yeah, exactly. So, and the other way around, an electric motor. What's an electric motor? An electric motor is the same process in reverse. Okay, so now you're feeding electricity to copper coils, which is then spinning a magneto, which is now an electric, you know, drill or whatever. So there's this very intrinsic relationship between magnetism and electricity, and in this case we're calling it electromagnetism. So we're looking for fields. Now, electromagnetic fields that, if they are man-made, okay, are axial. In other words, here's an axis, here's an axis, here's an axis, right? So you will see, as you know, investigators have seen, if you come up on a field with an axial device, this is an axial device, this is an axial device that actually shows you the direction that it's running in. You'll notice with a K2, you come up to a wall that's got electromagnetic stuff in it, and you'll see, wow, look at that, I'm going into the red, but I can go like this, okay, and all of a sudden it's nothing, right? Or I can go like this, and it's nothing. So one of the things that's really important is if you are getting activity, you want to, especially in doing base readings, you're going to like find something, and if you find something, especially if something goes into the red, it's not going to be a paranormal event, or if it is, you're dead. So the paranormal event stuff generally doesn't get past the third light on these, right? So this is just a very general, communication and base readings device. When we actually get into numbers, we'll get into the other meters. So always remember, these devices are axial, so they will read on axis. So what we're looking at here, the measurements that we're looking at here are in milligauss. Okay, so that's just a term that we want to get used to. We are reading stuff in milligauss. You may hear terms like fluxivity and stuff like that. Doesn't really relate to what this is, because we're essentially, as far as debunking and looking for man-made, electromagnetic fields, those are pretty static fields. It's coming from a bad ground. It's coming from a lot of times like lighting stuff that isn't done properly, right? Like when you have a light dimmer, there are like proper ways to do it, and then there are cheap bad ways to do it. And the bad ways, if you dim it, you'll get a truckload of EMF coming off that. You'll see that a lot. As Joe knows in his house, you can actually hold bread up and toast it. This device here, really good for, it's small, it's portable, and if you're with WCPRS, you get a flashlight in the front. But this is a good communication device.
What's the